Our solutions to perfect problem 7 for math 60. 4 parts here. First part, we're told that a line goes through these points, 2, -1, and 5, 1. And we're asked to determine the slope of the line. To figure that out, you need to know how to come up with the slope of the line. The formula for it is it's kind of the change in the y values divided by the change in the x values, which is often written as y2 minus y1 over x2 minus x1. So what you have to do is say, all right, I got 2 points here, 2, -1, and 5, 1. And what I will do is call one of them x1, y1, and the other point x2, y2. So if, for example, I say 2, -1 is x1, y1, and 5, 1 is x2, y2, then I can plug them into this formula here. Let's see, y2 looks like I'm calling 1 y2, and y1 is -1, so I want 1 minus -1. And then x2 looks like that's 5 minus x1, which is 2. So what I have here, 1 minus -1 is the same as 1 plus 1, which is 2. And 5 minus 2 is just 3. So what I figured out is that this line has a slope of 2/3. And that's all at once from part 1. Part 2 tells you that line B is parallel to line A. All right, so first of all, because it's parallel, how about, you know what, I'm going to subscript these a little bit. I'm going to call this M with a little a underneath it, so I remember that this is the slope for line A. And that way I can say that the slope for line B is the exact same as the slope for line A, which is 2/3. And the reason they're the exact same is because it's parallel. So the slope for line B is equal to 2/3. And slope is y2 minus y1 over x2 minus x1. So what I can do is say, all right, I got 2 points here. One of them is -4, 3, and the other one is 5, y. And so if I call this x1, y1, and this x2, y2, I can plug them into my slope formula and say, all right, y2 minus y1 over x2 minus x1. And that's equal to 2/3. I guess that's the key to this problem, is that this slope, this thing that I calculate, has to be equal to 2/3. So really what I have is an equation here. I have, maybe I'll rewrite it, y minus 3 divided by 5 minus -4 is 9. I have that that's equal to 2/3. And so what I want to do is solve this equation, solve this linear equation. There's a couple different ways you can solve this linear equation. One way would be to multiply both sides of the equation by 9 to clear the denominators. If you multiplied both sides of the equation by 9, maybe I need to write that in another color here. Multiply this side by 9, and this side by 9, really 9 over 1. Maybe I should have written as 9 over 1. Maybe that'll be easier for people to see. What will end up happening is this 9 and this 9 cancel out, and on the left side I'm just left with y minus 3. And on the right side, I got, maybe I should cross them out to show that they're canceling out. On the right side here, this 3 and kind of 3 from this 9 cancel out. And so what I'm left with, I guess I should put 1s where I cancel stuff out, is just 2 times 3. In other words, I'm left with just 6. So to solve for y, I could add 3 to both sides of the equation and get y equals 9. So I think what it's asking for is what is y? I just figured out y. Y is equal to 9. Kind of tricky, I thought. But if that makes sense to you, what you'll see is part 3 is very similar to that. So let's see, part 3 over here. Maybe I need to split these up a little better. So this is all 1 up top. And then this was all 2 over here. Oh, that's not true. This is all 2. So then I can do part 3 over here in the corner. Part 3 tells me that line C is perpendicular to these lines A and B. And so what that tells me is that the slope for C is not the same as the slope for A and B, which was 2/3, but it's the negative reciprocal of that. In other words, change the sign, now it's negative instead of positive, and flip that fraction upside down, now it's 3/2 instead of 2/3. The slope for C is negative 3/2. So it tells me that line C is perpendicular to lines A and B, and it goes through the origin. That's key. It goes through the point 0, 0. So what it wants me to do is find 2 more points that line C goes through. There's a few different ways you could do this. I think the easiest is to think about it as rise over run. Negative 3 divided by 2 is rise over run. So I start out at 0, 0, and then every time I go up by negative 3, in other words down 3, I go over by 2. So I start out at 0, 0, and then I go up by 3. No, up by negative 3. When you go up by negative 3, you're going down by 3. When you go down by 3, you're taking away 3 from your y coordinate. So this will become negative 3. Started out at 0, now it's down at negative 3. And every time I do that, I go to the right by 2. So from 0, if I go right by 2, I end up at 2. And if I do that again, if I went right 2 from 2, I'd get all the way up to 4. If I went down 3 from negative 3, I'd get all the way over to negative 6. So I think there's a lot of different ways you can do it. You can do it algebraically. You can do it by drawing a picture. But I think what I would do is write it like this and call these my answers. And then maybe parenthetically note negative 2, positive 3, negative 4, positive 6, positive 4, negative 9, and many others. Would also work. So I think the ones we found are these two right here are the easiest, but you're free to find other points too. And here's some of the other ones that would work. But really anything that would be on this line, and the line that goes through the origin, then goes down 3 over 2. I think once we do part 4, part 3 will be easier to see. All right, part 4 here. Basically what we're asked to do is sketch lines A, B, and C. And then we can kind of use that to check our answers. So let me draw some axes here. Line A goes through the points 2, negative 1, and 5, positive 1. So 2, 1, 2, negative 1, be this guy right here. And 5, 1, 2, 3, 4, 5, positive 1, be this guy right here. And so I'll try my best to draw a straight line that goes through those 2 points. It's decent, not the straightest line. Maybe I'll try it again. Probably don't care how straight my line is, so I'll just call that good. Here's line A. We figured out in part 1 that line A had a slope of 2/3. The line has a slope of 2/3. That means when you go up by 2, you go over by 3. That looks right, right? Go up 2, over 3, you land back on the line. That's a good thing. Looks like I got that one right. What about line B? Well, let's see. Line B is parallel to line A, and it goes through the point negative 4, 3. 1, 2, 3, 4. 1, 2, 3. Goes through this point right here. And then it goes through 5, comma, y. And I had to figure out what y was. And I think it's 9. Let's see if that works. 1, 2, 3, 4, 5. 9 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Way up top here. So 5, 9 would be right around in there, I guess. And if you try your best to connect those with a straight-ish line, get something that looks like that. And sure, A and B look parallel, or at least parallel enough. You know, it's not a great picture, but I think if I drew it really carefully, they'd look parallel. All right, call that good. What about part C? Part C says that line C is perpendicular to lines A and B. Okay, and it goes through the origin. Here's the origin right here. Wanted me to find two other points. Well, let's see, 2, -3. 1, 2, 1, 2, 3. This guy down here. And 4, -6. 1, 2, 3, 4. 3, 4, 5, 6. It's right here, and I guess I'm labeling these points. This is 2, -3. 4, -6. And if I connect these guys with the straightish line, I get something that looks something like this. And sure enough, it does look perpendicular, right? It looks perpendicular to A and B. I mean, up to the fact that I'm a terrible artist and none of these lines are straight. But the red and the blue one look more or less parallel, and the green one looks perpendicular. So I think I'm going to call that my picture and call this good, and end the video there.